Hello everybody, I welcome you all to NKS Geology class. Today I will discuss about the cubic crystal system in their classes. What are the symmetry elements? What are the minerals that crystallize in these systems? In these classes of cubic system, then what is their stereo diagram? Let us discuss. So, in case of cubic system, there are three crystal axes which are designated as A1, A2, A3. They are equal in length, they are orthogonal or mutually perpendicular to each other. In HM notation, the first number here refers to the three crystal axes A1, A2, A3 axis. The second number refers to four diagonal directions of threefold symmetry between the corners of the cube, and the third number symbol, if present, it refers to symmetry elements between six pairs of opposite edges. So, first number refers to three axes. So, there are three crystal axes. So, first number refers to three crystal axes. Second number refers to four diagonal directions of threefold symmetry between the corners of the cube, and the third number, a symbol, it represents the six pairs of opposite edges, symmetry element between the six pairs of opposite edges. So, if we remember this, we can draw the stereo diagrams. Let us know what are the five classes of the cubic system. These are 4 by m, 3 bar, 2 by m, 4 bar, 3m, 4, 3, 2, 2 by m, 3 bar, 2, 3. And this is the normal class or holoidal class or hexoctahedral class. The other symbol of this class is M3m. The short form of 4 by m, 3 bar, 2 by m is M3m. It is having 3 axes of 4 fold, these are axial, 4 axes of 3 fold, these are diagonal between the corners of the cube, and 6 axes of 2 fold, diagonal directions of 2 fold rotation involving the edges of the cube. There are 9 planes, A center. If you draw a cube, then these three axes, these are the axes of four-fold symmetry, Then when you talk about the axis of three-fold symmetry, these corners, the axis passing through the corners, opposite corners. There are 8 corners. So, this corner, this is one axis. This corner, another one axis. This corner, another axis. This corner, another axis. So, 4 axes of three-fold. This corner, this edge center, this is one axis of 2-fold. So, there are 12 edges, so 6 axes of 2-fold symmetry. This is about the axis symmetry. Then, plane of symmetry, there are 9 planes. If you see a cube, what are these 9 planes? This is one plane. This is another plane. This is another plane. These are 3 axial. Then this is another plane. This is another plane. 2 diagonal. This is another plane. This is another plane. 2 diagonal. This is another plane. This is another plane. 2 diagonal. So 6 diagonal, 3 axial, so 9 planes. A center of symmetry is present. Center of symmetry is present. Same thing in case of tetragonal system, but we have, in case of tetragonal system, we have 5 planes. Why? This is one plane, and this is one plane, this is one plane, this is one plane, this is one plane. This is not a plane, these are not planes, because they will not form mirror image of each other. That's why we have 5 planes in case of tetragonal system, but we have 9 planes in case of cubic system, because in cube we do not have these rectangular faces. All faces are squares. All faces are squares. That's why we have here another 2, here another 2, then this is 2, then 3 axial, 3 axial, 3 axial. So 9 planes of symmetry. In case of cube, 13 axes of center, 13 axes of symmetry, and 1 center of symmetry. Let us discuss 4 by m, 3 by 2 by m. So this is the symmetry element, and it is the highest symmetry possible in all crystals. Highest symmetry possible in all system. The forms are cube. Cube is called hexahedron, then octahedron 8 faced, rhomb-dodecahedron 12 faced, tetrahexahedron 24 faced, trapezoid 24 faced, trisoctahedron 24 faced, hexoctahedron 48 faces. Here a number of minerals occur with this class: galena, spinel group, garnet, halite, chlorite, diamond, sylvite, silver, gold, copper, cuprite, analcime, lazurite, uraninite. All these are minerals which crystallize in normal class of cubic system. And this is the stereo diagram. This is the horizontal plane of symmetry. These are the axial plane of symmetry. These are horizontal axis of symmetry. These are horizontal planes of symmetry. Sorry, these are vertical planes of symmetry along the axis. This is the horizontal plane of symmetry. So 3 planes along axis, and we have 6 diagonal planes. This is one diagonal plane, this is another diagonal plane, this is another diagonal plane, this is another 4 diagonal planes. This is one diagonal plane, this is another diagonal plane. So 6 diagonal planes. So 9 planes. Then let us show 13 axes. What are the 13 axes? This is one axis of 4 pole, that is A3. This is one axis of 4 pole. This is one axis of 4 pole. So 3 axes of 4 pole. This is a axis obliquely present through the center. This is another axis obliquely present through the center. This is another axis obliquely present through the center. This is one axis, rotor inversion axis, 3-fold rotor inversion axis, shown like this. So these are the 3-fold, 4 axis of 3-fold, 4 axis of 3-fold. Then we have the 6 axis of 2-fold. This is one axis, 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 this is one axis. So these are the 6 axis of 2-fold. So 13 axis of symmetry is there, and center of symmetry is there, and all these segments, they contain faces. one is the mirror image of the other. So 24 upper faces, 24 bottom faces. 4 bar 3m, it is hex tetrahedral class which contains half the number of faces of the normal class. Here 3 axes of 4-fold rotor inversion, 4 axes of 3-fold rotation, 6 mirror planes. These are the 6 mirror planes. Common forms tetrahedron, tristetrahedron, delta dodecahedron, but tetragon, tritetrahedron or and hexatetrahedron. Minerals are tetrahedrite, tennantite, sphalerite, boracite. These are the minerals which crystallize with this system. Common form is hexatetrahedron. It is 24 faced and can be viewed as a tetrahedron over each face of which there have been raised 6 faces. In tetrahedron there are 4 faces. In tetrahedron there are 4 faces. So this is one face, this is one face, this is another face, then this is another face. So on each face there has been raised 6 faces. So there will be 24, 6 into 4, 24 faces. So hexatetrahedral class, and here we have 24 faces, 12 on the top on the opposite side, 12 on the bottom on the opposite side. Alternately 12 faces on the top and 12 faces on the bottom. So that's why these 6 faces they have been made solid. These 6 faces they have been made solid. These 6 faces they have been made solid. And these 6 faces they have been made open dots because they occur on the lower part. And we have it is 4 bar 3m, it is 4 bar 3m. So this is 3 axis 2-fold, this is 4 axis 3-fold. So this is 1 axis 3-fold, this is 1 axis 3-fold, this is 1 axis 3-fold, 1 axis 3-fold. Then 6 mirror planes. So this is 1 mirror plane, this is 1, 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 this is 1. 6 mirror planes. And there is no axis of 2-fold symmetry. So this will not be 2-fold. 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 This will not be 2-fold because 2-fold symmetry is not there. Only 3-fold axis is there. These are the 3-fold axis. These are the 3-fold axis. This is not there. This is not there. This is not there. This is not there. So this is only. These are the planes. 6 mirror planes. This is a mirror plane. 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 6 mirror planes are there, and 4 axis 3-fold axis are there. So this is wrongly shown here. So we have to remove these axis 2-fold symmetry symbols, but only these are the planes of symmetry. And the minerals are tetrahedrite, tennantite, sphalerite, boracite, these are the minerals which crystallize in these systems. So here this has been wrongly shown here. This is wrong, this is wrong, this is wrong, this is wrong. Because we do not have a twofold axis. One axis of fourfold proton inversion. These are the these are the four axes of threefold, and we have three mirror planes. We have six mirror planes. So the six mirror planes I have shown. This one, this one, this one, this one, this one, this one, and this is not twofold symmetry. So twofold symmetry is not there in 4 bar 3m. So this is about the 4 bar 3m class, or it is hexatetrahedral class, hexatetrahedral class. Then let us come to 432, which is the gyroidal class. It is having one axis of fourfold, sorry, three axis of fourfold, four axis of threefold, six axis of twofold. So only axial class, hollow axial class. This is hollow axial class. Common form is gyroid, which is 24 faced. It is pentagon trisoctahedron. Trisoctahedron. It is otherwise called pentagon trisoctahedron. Reduced enantiomorphic form because it is a hollow axial class. And here each face is a pentagon, and on the face of octahedron we find the development of three faces. So altogether there will be 8 into 3, 24 faces. So it is only axial class. So this is the axis of fourfold symmetry. This is fourfold symmetry. This is one axis. This is one axis, C axis or A3 axis. This is A2 axis. This is A1 axis. These are the three axes of fourfold. These are the three axes of fourfold. Then these are the axis of threefold. Four axis of threefold. Four axis of threefold. Then we have six axis twofold. So this is one six axis. This is one six axis of twofold. Then these are the axes. Sorry, these are the axes. These are the axes of twofold symmetry. These are the axes of twofold. This is the axis of twofold. This is another axis of twofold. So there are six axes of twofold. And as these are the axes, only axes, no planes. So for each there will be three solid faces on the top, alternating with three open faces at the bottom. Three solid faces on the top, three solid faces on the bottom. So this has been shown here: three solid, three open dots, 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 three solid, three open dots. So there are 24 faces. They form the typical form, that is gyroid. Then 2 by m 3 bar, short form is m3. So three axes of twofold, three mirror planes perpendicular to them, these are the axial, and four axes of 4 axis of 3-fold rotor inversion. So this is 4 axis of 3-fold, this is 3 axis of 2-fold, 3 mirror planes. 3 axis of 2-fold along axial, 3 mirror planes, and 4 axis of 3-fold rotor inversion axis, diametral axis, forms pyretohedron or pentagonal dodecahedron or dihexahedron 12-faced. Common form is diploid. Dodecahedron is 12-faced. Diploid. Pyretohedron is 12-faced. It corresponds to half the number of faces of the hexoctahedron, diploid. Minerals are pyrite, cobaltite, smaltite, cloanthite. And here we have 3 faces, we have 12 faces on the top and 12 faces on the bottom, and they are mirror image of each other. So 12 faces, 6, 3, 3, 3, 3. There are 12 faces on the top and 12 faces on the bottom. And this is the axis of 2-fold symmetry. It is not 4-fold symmetry. These are the axis of 2-fold symmetry, dotted. Because we do not have. Yes, we have mirror planes perpendicular to the axis. If this is the axis, this is the mirror plane. If this is the axis, this is the mirror plane. If this is the axis 2-fold symmetry, this is the mirror plane. So we have the horizontal mirror plane, we have 2 vertical mirror planes passing through the axis. So 3 mirror planes. 3 mirror planes, one horizontal, this is horizontal, and these are the 2 axial. And these axes contain axis of 2-fold symmetry. So 3 axis of 2-fold and 3 plus 3 mirror planes. Then we have this rotor inversion axis, 4 rotor inversion axis, 3 bar rotor inversion axis. So this is the symmetry element of the diploidal class. As it is having horizontal plane of symmetry, it is possessing center of symmetry. It has a center of symmetry. It has a center of symmetry. So center of symmetry present. Center of symmetry is present here. In this class, center of symmetry is present. I forgot to mention here symmetry elements. Here 2 by m means it has a center of symmetry. 3 bar means 3 plus I. So it has center of symmetry. Center of symmetry is there. Center of symmetry present. So this is the form. We have 12 faces on the top and 12 faces on the bottom. They are mirror image of each other with horizontal plane of symmetry. This is the horizontal plane of symmetry. Then we have 2, 3, the tetrahedral class. This is a holoaxial class, enantiomorphic class. Common form is tetratoid. It is pentagon tritetrahedron class, or pentagon tritetrahedron is the name for tetratoid. Common mineral is cobaltite. 4 forms of tetratoid are there, which are enantiomorphic and two-fold symmetry, 3 axes which are axial. So these are the axial axis, two-fold symmetry. This is two-fold symmetry, axial. This is axial, two-fold symmetry. Then you have 4 axes of 3-fold. So this is 3-fold. This is threefold. This is threefold. So 4 axis threefold, and no other symmetry is there. That has been shown here, and we have, as we have axis of symmetry only, we have the 3 upper faces, 6 upper faces which are solid dots, and they have 6 open dots in the lower part. So 6 bottom faces, 6 upper faces, and in this manner the faces occur in tetratoid. So these are the symbols, these are the stereo diagrams. So 2, 3, we have 3 solid dots on the top, 3 open dots at the bottom. So this is one axis of twofold, this is one axis of twofold, this is one axis of twofold. See, tetratoid. In 2 by m 3 bar, it has center of symmetry, it has horizontal plane of symmetry. So this is solid, and this is twofold, this is twofold, this is twofold, and along this we have vertical planes of symmetry. So for upper 12 faces there are lower 12 faces. That's why these are bullseye. Solid, open, solid, open. Upper 12, lower 12 faces. Common is diploid. And in 432 24 faced is the guide order class, only hollow axial class, no horizontal plane of symmetry. This is dotted, and we have 4 axis of threefold, 3 axis of fourfold, and 6 axis of twofold. 6 axis of twofold. Then we have alternately occurring faces. We have alternately occurring solid and open. Solid and open, they alternately occur. Upper hemisphere, lower hemisphere, upper hemisphere, lower hemisphere, they alternately occur. So these are the alternately they occur. They alternately occur. They alternately occur. See, alternately occur. Alternately they occur. This is the guided, typical guided form. Then this is the hexoctahedral class. We have 48 faced solid, 24 faces on the top, 24 faces on the bottom, and they are a mirror image of each other. That's why this is the type of arrangement. And we have, this is the stereo diagram. So this is all about the stereo diagrams and the crystal systems that I wanted to discuss, and I thank you all for your patient hearing to my talk on 32 classes of symmetry.